Improved levels of performance, safety and comfort. Railway systems made in Germany have proved their worth all over the world for many years. Innovative railway technology has a long tradition in Germany. Here, trains were traveling at 230 kilometers an hour over 70 years ago. Even then, Hermann Kemper already had a vision of a railway operating without the use of wheels. In 1934, the certified engineer is granted a basic patent on the principle of a suspension railway. That his idea would actually work could at that time only be demonstrated experimentally. The high-performance electronic equipment necessary for the development of a magnetic induction suspension railway was not to be available for a good many years. Where advanced technologies are concerned, decades often elapse between discovery of ideas in principle and the technical possibility of their application. Things were no different for the maglev technology than for many other developments in air and space travel, or in computer and telecommunications technology. And as in any advanced technology, maglev development is continuing. Starting point for the maglev in Germany was a study commissioned in 1969 by the Federal Ministry of Transport into high-performance, high-speed railways. This encouraged consideration of totally new technologies, along with improvements in the performance of and modernization of wheel-on-rail technology to help solve traffic problems. Within 2 years, the first passenger-carrying proving vehicle is hovering along a test track about 700 meters long in Ottobrunn near Munich in a demonstration for former Minister of Transport Georg Leber. A range of different development possibilities are still being pursued. In 1972, a project group in Erlangen starts on the development of electrodynamic hovering, actuated by superconductive coils, operating on the principle of magnetic repulsion. The Erlangen proving vehicle does its first trial circuits on the test track later that same year. And 1 year later, the test vehicle Transrapid 04 is in action. On a test track mounted on pylons in Munich's Allach district, it later reaches speeds of over 250 kilometers an hour. The intention is now clear. The speed of a new non-contact railway system should substantially exceed that which the wheel-on-rail system can achieve economically and in an environmentally acceptable manner. With a component measuring testing unit, the Comet, proof is furnished in 1974. Accelerated by a sled fired by hot water rockets, the unmanned Comet hovers, lifted and driven electromagnetically, eventually reaching 401 kilometers an hour. These trials provide important information. At the same time, development of the long stator magnet driving technology is started. In this concept, an alternative to the line being followed at the time, the primary motive force is not installed in the vehicle, but in the actual track. The first passenger-carrying experimental vehicle with long stator drive and electromagnetic suspension system is commissioned in Kassel in 1976. After examination of a number of different developments, the federal government reaches a decision at the end of 1977. Since then, development in Germany has concentrated exclusively on the electromagnetic induction suspension system with long stator drive. Right from the start, economic viability has been of major importance. Rational construction and assembly procedures are developed to reduce the costs of modules and components of the new railway system as far as possible. less than 2 years later, they justify themselves on first application of the maglev principle. During IVA 1979, the International Traffic Exhibition in Hamburg, Transrapid 05 carries more than 50,000 passengers, including the then Federal President Walter Scheel. Operating a scheduled service, the first Transrapid to be licensed for passenger carrying hovers over the 900-meter-long track from Heiligengeistfeld to the exhibition ground. After the exhibition, the installation is re-erected and operated in Kassel in order to continue developing the system. The success of the Hamburg operation demonstrates that in order to test the maglev system as far as possible under service conditions in continuous operation and to develop it to production readiness, a test track is essential. In 1980, construction of the Transrapid Emsland test track commences. The TVE, which has a total length of 31.5 kilometers, including 2 loops, is constructed in 2 sections. Transrapid 06 goes into operation on a first section in 1983. After completion of the first section of the test track, Transrapid 06, which is constructed as a 2-section unit and designed for a maximum speed of 400 kilometers an hour, starts on a series of trials in continuous operation. In constructing the second section, the reinforced concrete and steel track supports have the driving component installations specified by computer. This guarantees an optimal level of accuracy. The second section of the test track is completed in 1987, and the test facility thus becomes the largest of its kind in the world and a magnet for visitors who want to experience a trip with Transrapid 06. These include Federal President at the time, Richard von Weizsäcker, who afterwards says, "Traveling in the Transrapid is more pleasant than traveling by road, on rails, or in the air."